Okay, here's some practice with interpreting position time graphs. So this is the motion of some object moving in one dimension, and so I plot the position of the on the x-axis along this vertical axis, and then the time along the horizontal axis. So here's the motion, and I messed up that line shouldn't be there. So this is, I want to make sure that was steep enough right there. So the question right here is, when did the car have the highest velocity? So how do we define the velocity, the average velocity in one dimension? It's the change in x over the change in time. That's the average. That's true. If the velocity is not changing, then the average is the instantaneous. Okay. Another way to do that is to think of what happens as delta t gets really small. But this looks like the slope. So if I'm talking about velocity from a position time graph, the velocity is the slope. So this is the same question as, when does it have the greatest slope? Okay, so I put some values on here just so we can check. I want to point out the first thing, that this is something that people will commonly do. It's like, oh, boom, it's right there. There, it's fastest. No. Highest does not always mean highest, right? That's the greatest position on the x-axis. That doesn't mean it's going the fastest there. So instead, we want to think about, where is the slope the greatest? So here, this slope and this slope are actually the same. This slope, it goes from, in just 1 second, from 5 seconds to 6 seconds, it goes up to 20 meters per second. Whereas right here, it goes to 20 meters per second in 2 seconds. So this has a greater slope. What about right here? Okay, this one goes from 30 to 0 in 1 second. So actually, this has the greatest slope. This is the greatest velocity, even though it's negative. So I think that's okay. So highest velocity would be from D to E. That's point D to point E. Second highest would be right here. Third highest would be these two right there. When did it change direction? Well, let's suppose I have this car right here on the x-axis, and it's moving. Once it starts going towards this way, it changed direction. So what's the difference in going that way and going that way? Well, this way would have a positive velocity. This way would have a negative velocity in one dimension. Okay, in 2 dimensions, you can't really say it that way. So where did the slope go from positive to negative? Well, it's right there, right? Because here it was moving in the positive direction. That's a positive slope. Here it has a negative slope. So point D is where it changed direction. How far did it go between 0 and 3? Now, here is a problem, right? This is easy. How far did it go from 2 to 3? Well, it's moving at a constant 20 meters per second. So I could say, switch back to black. I could say delta x equals v average delta t, and the average velocity is 20. So that one's easy. Okay. But right here, I can actually do the same thing. All I have to do is find the average. So let's call this delta x2, delta x, and this is going to be equal to, I'll write it out, 20 times 1 equals 20 meters. Right down here, I need to find the average velocity. Well, it starts at 0, it ends at 20, so the average velocity is going to be right here in the middle, which is 10 meters per second. So this is going to be 10 times 2, because it was 2 seconds, equals 20. So now the total change in displacement is going to be 20 plus 20 equals 40 meters. There you go.